Welcome to this educational video on energy systems. The content discussed in this video relates to Unit 3 of the VCE subject of Physical Education and relates to Area of Study 2 and dot point 3 of the Victorian curriculum. The learning intention. So by the end of the video, you'll have a sound understanding of the three energy systems, when they're used and how they work together during physical activity. So to move and to therefore be able to participate in physical activity, we all need energy. During this video, we will delve into how our body produces energy, also known as ATP, through our three energy systems. We will discover how the energy is stored, as well as how energy systems work together to provide our body with ATP, or energy, to allow us to move. So just a quick overview of this video. So we're going to summarize and describe the three energy systems. The first energy system is the ATP-PC energy system, also referred to as ATP-CP, and in America, it's referred to the ATP-PCR. So the PC stands for phosphate creatine. Therefore, it can be used interchangeably with CP, which is creatine phosphate, which is the same thing, or PCR, which is also phosphate creatine. The second energy system is the anaerobic glycolysis energy system, also referred to as the glycolytic, as well as the lactic acid system. The third energy system is the aerobic energy system. Mainly in America, they refer to this as the oxidative system because it uses oxygen to break down fuels into ATP. However, this is also done aerobically. The first two energy systems are anaerobic, and anaerobic means it does not require oxygen to break down the fuels into energy. But our third, which is the aerobic energy system, does require oxygen. We're going to have a look at the fuels and where these fuels are located within the body to create ATP, the rate of release or the power of each of the energy systems, and the duration of each of the systems. So here's the table I put together. Hopefully you find it useful. Feel free to screenshot and take notes. It just talks about all the different characteristics of the three energy systems. So for fuel source and fuel location of the ATP-PC system, the fuel is the PC, or the phosphate creatine, and is located within the muscle. There's actually some stored PC within our muscle at all times. However, it only gives us 1 or 2 seconds max of energy, or ATP. So if we're to do some movement that takes more than 1 second, so maybe throwing a ball would be okay, we can just use our stored PC. But for any activity more than 1 or 2 seconds, our body would have to start, or our ATP-PC system would have to start replenishing the ATP. The anaerobic glycolysis system, however, uses carbohydrates, or CHO, as a fuel and breaks it down into glucose and glycogen before it's turned into ATP, or energy, and is also located within the muscle. The aerobic system, however, uses carbohydrates as well as fats, and it can be located, the carbohydrates are located in the blood, muscle and liver, and the fats, which are converted into free fatty acids or triglycerides, are located within the blood, the muscle and the adipose tissue. In very rare cases, the aerobic system can also use protein, but these are only for super long duration, such as super marathons, or if all other fuels are depleted, such as carbs and fats, and this would be in like a famine incidence, but predominantly the aerobic system uses carbohydrates and fats. The rate of energy, or the power So for the ATP system, is very high. So it has high power. So intensity, it's high intensity. Anaerobic glycolysis is still rather high, just not as high as ATP-PC. And the aerobic system has a lot lower. So for example, ATP-PC system, high intensity things such as throwing a shot put. Whereas aerobic has low power, things for like walking. The duration of energy release. So for ATP-PC system, it's very short. So it starts to deplete. It's pretty much depleted by the 15-second mark of activity when performing maximally. The anaerobic glycolysis system starts at the start of activity and starts to deplete at around the 90-second mark, whereas aerobic system also starts at the start of activity or exercise and contributes to ATP resynthesis until the very end of exercise, until you stop. So it's always contributing. Therefore, it has a very long duration of energy release. The last characteristic, the total ATP energy release per molecule. So ATP-PC has a very small energy release per molecule. The anaerobic glycolysis, still small, but not as small as the ATP-PC system. And the aerobic system is very large. So carbohydrates, it provides us about 36 or 38 lots of energy per molecule. And triglycerides are 387. So this is like 387 more times energy per one molecule of a triglyceride, which is a fat, than than a PC molecule. However, although it provides us lots more energy, it is a lot harder for our body to break down a triglyceride or carbohydrate. It takes more energy to do so. So yes, it does give us more energy, but don't be sucked into thinking it has more power because it's just over a long duration, whereas ATP-PC is more fast and high power. So this is a table of the interplay of the energy systems. So as you can see, all three systems contribute at the start of the activity. We can see the PC system, or here it's referred to as the phosphate energy system. So phosphate, PC, is dominant at the start until around, looks about like the 9-second mark here, where the anaerobic glycolysis system becomes dominant. So we see that crossover. The anaerobic glycolysis system is still dominant until around the 35, 40-second mark, where the aerobic energy or the aerobic energy system becomes dominant for the remainder of the activity until the end. So you can see at the 30-second mark, all three systems are still contributing to ATP, but the anaerobic system is dominant. However, at the 180-second mark, or the 3-minute mark, the aerobic energy system is dominant, even though the other two are contributing and not contributing as much as the aerobic energy system. So this is a good graph to refer to. So we're just going to go through some worked examples and questions. So which energy system is predominantly used in a 100-meter sprint? So first we think of the intensity. It's high intensity, it's maximal. You want to finish this sprint as fast as you can, therefore it's high intensity. The duration, it's very short. So Usain Bolt has a world record at 9.58 seconds, so under 10 seconds. Therefore, the ATP-PC system is the predominant energy system during this race. So other examples of ATP-PC dominant activities or events: high jump, short duration, only takes a few seconds. High intensity, you want to jump as high as you can, so that burst of energy, therefore it needs the PC system. Long jump, same goes. Shot put, again, only takes a few seconds and you want to do it at maximal intensity. And maybe like a fast break in basketball or any sport really. You get the ball, you want to sprint down the other side of the court as quickly as you can. Short duration, high intensity. Therefore, the ATP PC system is dominant. What running event would have the anaerobic energy system dominant for the majority of the race? So the world record is 43.03 seconds. So we know the duration is pretty quick because it's less than 90 seconds, but it's also more than that 10-second mark, which is the 100-meter sprint. Again, we're still working maximally. So the answer is the 400-meter race. So at about the 15-second mark, the ATP PC system would stop being the dominant energy system, and the anaerobic glycolysis system would take over as the dominant system for the remainder of the race. If the race went any longer, the aerobic energy system would take over. So 400-meter race is a good example. So some other examples of the ATP PC dominant activities or events: repeated leads or a circuit program. So question, Simon is about to finish his 3-kilometer run for the school cross-country day. He's 30 meters from the finishing line, so he sprints to overtake the person in front of him. Which energy system is contributing the greatest amount of ATP during the last 30 meters of the race? This one's a little bit more difficult. His intensity, he's sprinting at the end, so he's working at a high intensity compared to the rest of the race. However, duration is the main factor in this question. So although he's working at a higher intensity at the end of the race, it's still a long duration. So obviously this 3-kilometer race would take longer than 30 seconds. And we know at the, 90 seconds. And we know at the 90-second mark, the aerobic energy system becomes dominant. And once it's dominant, we also know it's dominant for the rest of the race, unless there's a break. However, we know in a cross country, it's a continuous sport, so you run the whole time, so there's no time to break to replenish those anaerobic systems. Therefore, the answer would be the aerobic energy system. However, if Simon ran 2.9 kilometers and had a cup of tea and had a chat with his friends and then just decided to sprint at the end, it might be a different story. He'd replenish his anaerobic and ATP PC systems, so they'd contribute more dominantly. But because cross country is continuous, that's why it's an aerobic energy system. So other sports or events that the aerobic system is dominant. So Ironman and marathons. So just try to think, if asked a question like this in a test or an exam, think of long duration and continuous sports. So Ironman goes for hours, marathon goes for over 2 hours, depends on how good you are as well. Does that make sense? Just a final tip. So remember that all 3 energy systems are contributing to the resynthesis of ATP at all times, unless they've depleted. So for example, in shot put, at the very start when you're doing shot put, the aerobic energy system is still contributing. It might be less than 1% because it's predominantly the ATP PC system, but they're all contributing unless they've depleted. So good luck with your studies. Hopefully this video helped. Remember to get out and exercise during your study. And when you do go out, whether it be a run or a kick of the football, whatever it might be, just try to relate all of your sport and exercise back to these energy systems as often as possible, and try to think which energy system would be dominant and when, as well as why. Hopefully this helped. All the best.